Okay, now we're going to look at oblique asymptotes and holes. First we'll look at holes in a graph. So this is kind of an interesting concept where the graph is continuous, it's a continuous function, but there's a break in it somewhere, and it's just a hole, and we'll take a look at a function that, a simple function that gives us one of those. So for example, f of x equals x over x. Well, this one seems kind of redundant, because most of us would say that, well, x over x just equals 1, except for that one case where you cannot divide by 0. So, in fact, this does not equal 1. It equals 1, comma, x cannot equal 0. So if you had to graph this, well, graphing the function y equals 1, so y equals 1 is just a horizontal line, horizontal line of y equal to 1. So it goes across here through y equal to 1. There's the x-axis, there's the y-axis. Except now, instead of at 1, it can't be defined there, so I can't have a dot there. So I'm just going to make a little more white out there, and then what we put in here is a hole. Okay, so that graph has a hole in it. Now what's interesting is the size of that hole. So theoretically it has a hole in it. There's a break there, you can't have a value there. But what is the width of one single number on the continuum? Well, it's funny because it's 0. So there's a hole there, but you could never see it. We put it there to symbolize it. There's a break there, but you could never actually see that hole because it has a size of 0. So now what about another example here? Well, notice that we were able to cancel that out because it was the same factor in the top and the bottom. So if you had another example, like say f of x equals maybe x minus 1 times x plus 2, so a factored quadratic. So you'd probably have to factor this to find this out, over x minus 1. Okay, so in order to look at this, you'd need to factor it. Now, notice that the factor on the top is the same as the bottom. Initially, based on what we've done already, you probably want to put a vertical asymptote at x equal to 1. But then you'd also have a 0 at x equal to 1, an x-intercept. Well, if there's a vertical asymptote there, you can't have a 0 there, so this would be a little bit hard to graph. So instead what you do is you cancel those out for everything except for the value of x that makes this 0, and that would be 1. So that equals x plus 2, comma, x cannot equal 1. Okay, so you don't have a vertical asymptote there, and you don't have a 0 at x equal to 1. You have neither. So when you're graphing this, the graph is just a linear function, y equals x plus 2. So it has a 2 on the, goes through 2 on the y-axis, okay, and it goes up with a slope of 1. So at x equal to 1, okay, there's 2, you're going to have a hole in the graph. And the function would look like this. Okay. Now, this is going to happen for any function where the top cancels out with the bottom. So I'll do one more example. Something like this. So let's do f of x equals x plus 2, x minus 3, x plus 1, all over, let's do x plus 2 again, and x minus 5. So if you had that, well, now you notice that x plus 2 is a common factor between the two, so you cancel those out, and you end up saying this is x minus 3 times x plus 1 all over x minus 5, and you also have to write the restriction here, x cannot equal negative 2. So this represents the hole in the graph, okay, when you have to cancel that out. So what does this graph look like? Well, let's check here. So x, y. The degree of the top is bigger than the bottom by 1. So you're going to have a linear asymptote, basically. So it's not going to have a horizontal asymptote. So you have a vertical asymptote at 5. So x equal to 5. Does not exist at x equal to -2. So I'm going to put approximately -2 there. It has a 0 at x equal to 3 and -1. Okay, it has zeros there. And so what happens? Well, this is going to take off this way over here. And because it can't come through the x-axis, there's no more zeros, it must go like that. And then over here, it's going to take off this way, like a line. Okay. And then in between, what's going to happen? Well, we'd have to check out the values in here. But basically, what's going to happen over here is you're going to have a hole where x equals -2. Okay, so when you check out at 3, there's a spot there that's going to go through. So f of 4 is 4 negative or positive when you do this. So 4 minus 3, so the top is going to be positive, the bottom will be negative. So it's going to come up like this to the 3. And then between -1 and 3, well, let's try 0. So negative, positive, over a negative, it's going to be positive. So it's going to come up like this. It's going to come back down, hit 1. Okay. And then it's going to come along here, and there'll be a hole there, and then it heads down to that. And that's what that graph would look like with the hole in it at x equal to -2. Now what happens when you have a common factor, except when it factors out, it ends up not being a hole? Let's take a look at a case like that where you think you might have a hole in it, but you don't actually. So something like f of x equals x minus 4 times x plus 3 times x minus 5 all over x plus 3 squared. Okay, so we've got a common factor in the top and the bottom here, but the one on the bottom is squared. If on the top it's squared, it's a different story. But if on the bottom it's squared, well, then we've got a problem here that, well, you can rewrite this x minus 4 times, well, I'm going to cancel one of the x plus 3's out, so I'm going to have x minus 5 left on the top, and on the bottom I'll only have an x plus 3. Now this doesn't change the function much, except for it doesn't have a 0 at x equal to -3. It looked like it might have here, but it doesn't now. And it looked like it might have a hole in it at x equal to -3, but it doesn't because one of the factors is squared. So you in fact do have a vertical asymptote at x equal to -3. Okay, so from this look to this look is very different. So now you have a vertical asymptote here. If it was squared on the top and not on the bottom, then you'd cancel it out, and x could not equal -3, and you'd have a 0 there. But then you'd have a hole right on the x-axis, right at that 0. Okay, so it wouldn't actually be a 0 because x couldn't equal -3. Okay, so I hope that helps for trying to figure out whether you got a hole in the graph or not. If you have a common factor on the top and the bottom, you will most likely have a hole, or in this case, you wouldn't. Okay.